Hey everyone, this is Drishanvik. Welcome to the walkthrough of our project, which is Amazon Prime TV shows and movies, the EDA analysis. So let's deep dive into this. So the first one is project summary. So basically, the goal of the EDA analysis of this particular project is to drive or extract actionable insights from Amazon Prime content catalog by analyzing over 9,000 titles and 124,000 cast credits. We aim to understand the content diversity by genre and the type of the content. The second one is explore regional production contributions. The third one is analyze trends in content release over time to identify the patterns in the trends. The fourth one is examine the popular metrics like IMDb and TMDB scores for popularity. And the fifth one is identify the patterns in cast and director roles and their frequency. So let's, deep dive into steps while conducting ED analysis of this project. Before diving into data cleaning and data visualization process, it's better to understand the business context or a business problem so that we can come up with the questions like why data exists, what businesses question need answers, and how our analysis contributes to a decision making, which is very important for the stakeholders. The second one is data collection and cleaning. The basically our analysis consists of the two files. The first one is title.csv and the second one is credit.csv. That contains media information and cast crew data from Amazon Prime Video. So we basically merge these two data sets on the basis of common column. We will discuss it later. The third one is data visualization. So basically we can, represent the data in the form of visual format using various, charts like box plot, bar plot, count plot, histogram, heat map, right? Pie charts, right? So this enhances basically data storytelling and insight presentation, which looks like a beautiful way to represent the data, right, in the form of charts. This will also be discussed with in a later part. The fourth one is very important: key findings and interpretations. Whatever we visualize, right, we can derive key insights or key findings from that particular visualization so that stakeholders get to know about this is the business problem and we are going to solve this problem with this particular technique or a strategy, right? And the fifth one is recommendations. It's basically a action blueprint, or you can say data driven suggestions for a business action. So this is the GitHub link. Okay, I uploaded this whole project in a GitHub file, so this is the link. The Then comes the main part, problem statement. So basically, this data set was created to analyze all shows available on Amazon Prime Video, whether it's a TV show or whether it's a movies, right? Allowing us to extract valuable insights such as content diversity, which basically questions what genre and categories dominate the platform. Okay, it's basically a ratio of TV shows versus movies. Then comes the regional availability. How does content distribution vary across different categories? The third one is trends over time. How has Amazon Prime content library evolved? And the fourth one is IMDb ratings and popularity. What are the highest rated and most popular shows on the platform? These are the basically the business questions. And we are going to solve these questions, right? Further. So let's come the data cleaning part. Before moving ahead with the data cleaning, it's important to import our main libraries. So we import Pandas, we import NumPy, we import Matplotlib, Seaborn for data visualization part. Okay, and then comes the fetching the first data set, which is as I told you that there are two data sets. The first one is title.csv and the second one is credit.csv. So we basically fetch both these data sets. Okay, and while driving the input, it comes the unique columns of this data sets of the title data set, and for the credit data set, these are the columns. Now it's time to merge these two data sets, okay, on the basis of a column, that is ID. After merging these two data sets, here comes the output. So this is the merged data of the two data sets which we merged it. So this is the output, right? Now comes to identify how many rows and columns are there in a merged data set. So this is basically the function data.shape. It basically gives the number of rows and columns in a merged data set. And then we can check all the columns in a merged data set before, diving into cleaning the data or visualization part. So these are the unique columns of a merged data set. Okay. Then we can, gain some information from this data set. So these are the information, right? It basically, fetches the column like ID, title, type, description, release year, a certification, runtime, genre, right? And so on. Now comes the data description part. So basically, as I told you that there are two data sets. The first one is title.csv and the second one is credit.csv. So it basically, describes the two data sets information. So the data set has the following columns. I'm talking about the merged data set here. Now, I'm not talking about title.csv and credit.csv because earlier it was two data sets. Now we, combine these two data sets into a single data set. And then we gonna perform the calculations and all the things basically on this merged data set. So so the merged data set has the following columns: ID, it's a unique identifier of each title, title of the movie or a TV show, type is whether it's a TV show or a movie, description, a brief description about the title, which is unique because each and every description of the movie is unique. It's not like a duplicate one, but let's find it whether it's duplicate or not. It's then the comes the release year of the title, like which year the title gonna released. A certification, whether it's a R rating or something else, right? We can, check further in this video. Runtime, genres, production countries, season, number of seasons, IMDb ID. It's a unique identifier, IMDb identifier for the title. IMDb score, right? Which basically user gives on the IMDb platform. IMDb votes, how many, IMDb votes are associated with that particular movie or a TV show. TMDB popularity, TMDB score, person ID, name, character, and role. Whether the role, was from an actor or a director in a movie. Now comes the data cleaning part. So we're gonna check missing or null values from in a merged data set. So this is the function. So here, we got to know that there are so many null and missing values. In a description column, there are 91. In a certification, there are 67,640. In a season column, there are 1,16,194. It's a huge number. IMDb ID, which is 5303, missing value. IMDb score, IMDb votes, TMDB popularity, TMDB score, character, right? So after analyzing the null and missing values, now the next step is to clean it. Okay. So we're gonna drop all the null values from the description column. So here's the function, right? And then we're gonna, replace all the null and missing values, okay, of a certification through mod. Then we're gonna replace null values in a season column with zero because zero makes in a better way. And then we're gonna drop null values from IMDb ID because it's a unique identifier and there are no missing or null values in that particular column. Okay. Then we're gonna replace the null values of IMDb score column with the mean of IMDb score. It means basically we are filling the null values with the mean or mode by replacing it with mean or mode. It is as good as that, right? Then we gonna run this function to make sure that how many rows and columns are there. Okay. It's very important after data cleaning process. It's important to check the number of rows and columns before, moving forward with any other calculations, right? Just to make sure that the nature of the data set cannot be changed. If we delighted to change it according to our analysis, we can do. But neither but this is not a like a recommendation strategy, but yeah, it's important to analyze the data set, okay, after cleaning. So now it's the time to replace null values of IMDb votes column with zero, okay, like we did for season column. Then we're gonna replace null values in TMDB popularity column with the mean, okay, TMDB score with the mean, replacing the TMDB score column null values with mean, okay. Now we're gonna check again whether the null values are, you know, there or not after performing calculations. As you can see, there are no null values. All the null values are successfully removed from the respective columns. Okay. Now it's time to check the rows and columns of the data set after data cleaning process. So yeah, this is the final output of a number of rows, which is 1,90,022 and columns is 90. Okay. So after handling missing or null values, now it's time to check the duplicates in our data set. Checking duplicate values. So this is the function. Now we, analyze that there are 168 duplicate values in our data set, right? So we're gonna drop all these duplicate values from the merged data set before moving forward with data visualization part. So yeah, dropping all the duplicate values from the data set. So this is the function. It's gonna drop all the duplicate values which is existed in uh, different columns. Okay. Now it's time to check the data type, whether the column data is integer or whether the column data is a string, right? So to check the data type of a data set, this is the function data.dtypes. It will give me the information about the data types of a different column, right? Now it's time to check the statistical description of a particular data set, like to know more about median, mean, okay, standard deviation, first quartile, second quartile, third quartile, right, and so forth. So this is basically the table which represents the statistical description of the merged data set. Okay. Now comes the data visualization part. So basically, data visualization in simpler terms is basically mean the graphical representation of a clean data, of a information in a data which we clean it in the above process. By using different types of charts, maps, and graph visualization tool helps us to identify the patterns, trends, and outliers in the data. So, by using different types of charts, we can analyze that how many outliers are present in our database, in our data. Okay. And to basically identify the patterns. Okay. Like which chart basically gives me what kind of instances the chart gives me in order to solve the particular problem. Okay. So the first one is content type distribution. So basically, we gonna analyze the distribution of TV shows versus movies. So in this visualization, we can clearly see that movie ratio is higher than the TV shows. Okay. So yeah, as you can clearly see that the content type movie is dominated in this particular chart. So basically, it means that Amazon Prime focuses on movie rather than TV shows. Now the second one is top 10 genres in Amazon Prime. We're gonna identify the type of content which Amazon Prime is having. The top 10 genre, like whether it's a dream, whether user focuses on a drama content, whether user focuses on a romantic kind of movies and all stuff. So we're gonna see it in our visualization. So this is basically the chart which represents top 10 genres in Amazon Prime. As you can clearly infer that drama and comedy are the leading basically giants in this particular data set, in this particular visualization. So drama and comedy are leading as the most represented genre from this visualization. Okay. Now the third one is IMDb score distribution. So we can, represent this data in the form of histogram. So histogram basically groups the numerical data into different bins and shows how many values fall into each bin of that particular category, right? Using bars, we can use it. So this is the histogram of IMDb score distribution. So as you can see that there is a peak in the range of 6 to 8, right? And after that it's gonna drop. It's gonna fall down. So majority of titles scoring between 5.5 and 7.5. It can, take it as a 5.5 and 7.5 or a round figure like 6 to 8, right? So the peak occurs near a score of 6.5. After 6, the peak is higher. Okay. Indicates that this is the most common IMDb rating across the catalog. So 6.5 is the most common IMDb rating. as we can analyze from this visualization. Okay. The data is slightly left skewed. As you can clearly observe that the data is slightly left skewed, right? With fewer titles scoring extremely low, like below 4, and some are higher, right? So it basically the nature of this particular visualization is slightly left skewed. So now it's time to analyze the yearly release trend. How many, in which year the titles gonna released, or a movie or a TV show gonna released. We can, analyze this in a visualization. Okay. So in from this visualization, you can clearly observe that most of the titles are released in the year after 2015, right? This is the peak, as you can see in this visualization. So yeah, findings can be, we can observe clearly that there is some notable increase in the release trend after 2014, as I said, followed by the peak around 2018 to 2020. So yeah, after 2015, there's a peak, okay, and it goes another peak at 2020, slightly higher, right, and then it gone down, okay. So we can simply state it that most of the movies are released after 2025 or 2015, and it gonna the peak at 2018 to 20 period, and then that's it, okay, in the period of 2018 to 2020, and after 2015 the most of the movies are released, right? So yeah, now it's time to analyze the top production countries, like which countries have the top producing movie are the top producers in terms of movies or TV shows. We can analyze this particular problem, okay. So yeah, we can represent this particular problem in the form of pie chart. Okay. So yeah, see this visualization. We can clearly observe that most of the movies or titles, 74.9%. Okay. So US is basically the leading factor, right? In terms of like across different countries like India, United Kingdom, Canada, and Japan. Okay. So more than 50% of the movies of the content comes from the USA country, with significant contribution in UK, Canada, and India respectively, as you can clearly observe in this visualization. Yeah. So now it's time to analyze the problem of IMDb score versus TMDb score using scatter plot. Okay. So yeah, this is the basically the representation. So we can clearly observe that there is a strong to moderate positive correlation between these two variables, between these two metrics. Okay. And there are few points that fall off the line, highlighting some rating inconsistencies across the platforms. So there are little bit outliers. Okay. As you can see in this visualization. Now it's time to know the runtime. Okay. What is the duration of movies and TV shows which the user is consuming? Okay. In Amazon Prime. So we can, again represent this particular problem in the form of histogram. So this is a histogram. And yeah, see, the runtime of movies and TV shows is slightly higher, okay, after 50. So most of the movies have a runtime of 70 to 90 minutes, okay, in the range of 50 to 100, right? We can infer it simply, right? So this indicates that the runtime for most common movies and TV shows on Amazon Prime is ranging between 70 to 90 minutes, as I told. So yeah, see, in the previous distribution histogram, the nature of that particular chart is left skewed, right? As I told you. But in this visualization, you can see clearly that the chart is rightly skewed. Okay, having longer tail on the right side of the peak. See this area, right? So considering the fact that there are more number of movies and TV shows fall between 60 to 100 minutes. So most of the users, saw movies and TV shows which has a runtime of 70 to 90 minutes. Okay. We can analyze this in this visualization. Now it's time to, analyze the knowing the role distribution. Okay. So see, we can, simply plot this particular problem in the form of bar chart. Sorry, in the form of count plot. So yeah, this is the basically the visualization. Actor. So actor is leading. So the most of the movies and TV shows have actors, not directors. Okay, we can simply infer it from this visualization. Now it's time to analyze the number of seasons. Okay, so this is basically the histogram. So yeah, the peak is at 1. Okay, yeah. So this histogram shows peak around 1 constitutes that seasons are only applicable to TV shows, not movies, because movies are, unique, right? So the peak is higher in terms of TV shows, not movies, right? And it's 1. So most of the TV shows on Amazon Prime have 1 to 3 seasons. After that, there are no seasons available for that particular show. Okay, we can infer it from this visualization. Now it's time to analyze the A certification, like which movie has a R certification, which movie has a PT certification, and all. We can, simply see it from this visualization. So yeah, see, we can, analyze this particular problem using bar plot. Okay. So bar plot basically represents the quantity of each categories using bars. So yeah, most of the movies and TV shows have R certification, followed by PG-13, PG, Z, TV, MA, right? So the leading factor is R. Okay. So movies or TV shows having PG certification are at second position. Okay. So the first position is R certification. Then comes the PG-13. Then comes PG. Then comes G certification, and so forth. Now average ratings for each A certification. So these are the average ratings for each A certification. So basically, TV PG, TV MA, and TV 14 certified content have the highest average IMDb ratings, as you can see in this visualization, all scoring above 7. See, TV PG score above 7, okay, and this one, this is TV 14, and this is basically TVMA. So these three certifications have scored more than 7. It indicates that it has a highest average IMDb ratings. Okay, so basically it infers that, you know audience are more targeting towards mature television or a family show, right? General or mature television audiences are there. We can, plot this visualization using bar plot. Now it's time to analyze the IMDb scores by content type. So it basically represents the, IMDb scores using box plot to analyze like which content type has a higher IMDb scores. It's a movie or a TV show. See, this is basically the box plot. Okay. It basically represents the numerical data. So yeah, this is the show and this is the movie. Okay. You can see there are certain outliers as well. So see, TV shows have higher median as compared to movie. This you can see this line. This is nothing but the median itself. Okay, this is a median. So TV show tend to have a slightly higher median IMDb scores as compared to movie. Okay, and in terms of outliers, you can see that there are higher outliers in the movie as compared to TV shows. Okay, from this visualization, we can analyze these two findings. Now comes the top directors with most credits. So this is the director list. Okay, these are the top 10 director count. Okay, you can see using bar plot. So as you can see that in this visualization, Joseph Kane, the director, leads the position. It's basically score more than 40. Okay, followed by director Sam Newfield and Jay Chapman. respectively. Now it's time to, do multivariate analysis. This is a pair plot of more than two variables. Okay. Yeah, this is the pair plot. Okay. It basically analyzes the pairwise relationship between rating variables using pair plot. So the rating variables are IMDb score, TMDb score, IMDb votes or TMDb popularity. Okay, these are the metrics. So we're gonna plot this particular data in the form of pair plot. Yeah, this is the pair plot. Okay. Yeah. So see, in this visualization, we can analyze that IMDb score and IMDb votes shows a moderate to positive correlation. Okay. Indicated that titles with higher ratings tend to receive more viewer engagement, although there are some exceptions with many low rated had highly voted titles as well. Loosely correlation. So TMDB score and IMDb score appears loosely correlated. So TMDB score is this and IMDb score is this. Yeah. So this is basically loosely correlated. As you can see, there are certain, yeah, this is the representation of IMDb score and TMDB score. Not strongly correlation. So TMDB popularity does not strongly correlate with either IMDb votes or IMDb scores. Okay. So this is TMDB popularity. As you can see, there is nothing correlated in this particular visualization. Yeah. So we can infer it accordingly. Now, last but not the least is heat map analysis. Okay. So heat map is basically, a correlation or a relationship between two variables. Okay. Acting in a different direction. If one variable increases, the other one decreases. If one variable decreases, the other one gonna increase. It basically works accordingly. So this is the heat map. So, you know, it starts from 1 to minus 0 0.2. So 1 indicates that there is a strong or positive correlation, and minus 0.2 indicates that there is a negative correlation. Okay. So in this particular heat map, we can analyze that IMDb score and TMDB score has a strong to positive correlation because it has a value 0.62, right? And if we can determine the relationship between runtime and seasons, yeah. So the runtime and seasons have negatively are negatively correlated to each other because it has a value minus 0.3. So we can analyze in this particular heat map that runtime and seasons are negatively correlated to each other, while TMDB score and IMDb score are positively correlated to each other. Okay. So let's come with the conclusion part. So basically, this exploratory data analysis of the Amazon Prime Video, which basically consists of the TV shows or movies, has provided actionable insights into the platform content trends and user preferences. So as we can see in the content type distribution that the TV shows are the leading one as compared to movies. So Amazon Prime focuses only on TV shows, not movies. Okay. Drama and comedy are the most popular genres in the Amazon Prime Video. Okay. Majority of titles have higher IMDb ratings of 6 to 7, as we can see in the histogram. A large portion of content falls into R-rated certification, as we can see in the bar plot visualization, that a larger portion of content has R certification, not other certifications. Content with TV PG, TV MA, and T14, TV 14A certification tend to receive higher average IMDb score, showing a favorable audience reception because audiences are moved towards more mature and or a family oriented kind of stuff, right? Yeah. As you can see in the heat map visualization, we can analyze that seasons and runtime are negatively correlated to each other. So this is one of the analysis which we derived from this particular EDA. Now it's time to, recommend some actionable insights from that particular analysis. Okay. Since a majority of content have R certification, okay, it is highly recommended that Amazon Prime should focus on other certifications as well. Should, invest some efforts in other certifications to promote it or to attract larger amount of audience. Okay. Actor and director popularity to improve search and personalization. As you can see in the visualization, where actors are leading as compared to directors. Amazon Prime focuses on directors as well rather than actors. Okay. The most producing country we can see in the visualization is USA. So consider expanding content acquisition from other countries as well. Like there is a country like India, UK, Canada, Japan, to attract larger amount of audiences and to, cater to international needs. So since runtime of the TV shows is about 70 to 90 minutes, okay. So it's time to segment the user based on viewing patterns and recommend content aligned with their preferred runtimes. And after performing whole ED analysis, it has been seen that shorter series with multiple seasons may suggest higher periodic episodic engagement. So consider promoting or producing content in this format only. So this is all about the whole ED analysis of the Amazon Prime content. Thank you so much for watching this walk.